Okay, we're officially recording, and now I wanna show you another problem. It includes both M in two different directions. Also, you have axial forces, right? So again, just follow me. I just draw the figure. It's a charity block. And then let's see this axis. Let me just denote, for example, this is axis C, this is Y, axis Y, and yeah, and the vertical is, for example, X, right? Then if you have a force, maybe here, this is a force, vertical force is 20,000 pounds. Then if, let me show with the other color maybe better, right? If it did this on, let's see. Okay, this one is EVA is 3 inch, and this is, let's see, EZ, for example, 2.5 inch, right? Let's see, 3 inch and 2.5 inch. Okay, that's like eccentricity. And the other thing, let me show you the other color. Let's this dimension is 8 inch. And this dimension is 12 inch. Okay. So in this problem, we want to find the stresses with these four corners. So let's see, let me write A, B, C, and D, right? In this previous problem, last lecture, the problem was T-shape. There are lots of calculation. We should T-shape, find the center, find what's that? Moment of the inertial line process. But here it's just rectangular, which means the center just in the middle, right? That's the center in the middle. So, which means first we should to find first in this situation, you know, this EY makes the moment in direction the other direction, and also easy makes the moment in one direction. And now I want to start to derive figure, and just I want to ask you to help me to for the index of the moment or something like that, right? Just follow me. So again, let me just draw here again. I want to convert the force in the middle, because if you know, since these forces make the moment, right? Make the moment, you have a two moment and one compressive force, right? Every time we should apply the moment and the forces in the center of the shape. In T, for the T shape, you should find the center, but here is easy because we know the center of the rectangular in the middle, right? So, and for the P force is good, just P is the, you can put the P here. And now for the moment, let me ask you, yeah, if the force, yeah, let's see, this is direction of z, this is direction of y, and force p is in direction of x. For example, x is up, right? Force p in direction of x, ey here. Ey times p is the what's the moment? Moment in which direction? Direction of y, z, or x? For say that again. Yeah, in direction of z, exactly. If we have z here, yeah, this is y. P times Ey, we have a moment in direction of. Let me at the same time. I want to show you the two things, like in the 3D and the other things with the double arrow, right? At the same time. Then it is up to you to pick which one you are comfortable.
So in a way, are we looking at it as the moment is rotating along the y-axis, or?
Yeah, the moment in the P times Ey. Use the right hand rule, right? Ey times P, which means the moment in direction of z, right?
Yeah, and it's going to be counterclockwise, right?
So, okay, for the P, you know, here P, we can show the P like this. Yeah, that's a P. Okay. And now, okay, for the first one, the moment Ey times P in direction of z, right? It looks like maybe this one. We set mzz, or if you want, you can show with the double arrow, just mzz, right? Moment in direction of z, right? So use your right hand rule, and then your thumb show the direction of the moment, the direction of the moment in direction of z. Next question, what's the moment from Ez times P? What's the direction of that? Easy
direction.
Say that again.
The y direction.
Y direction. It look like this. MYY, or I can show that based on direction of thumb is MYY. In any case, that's fine. If you're comfortable with this, you can show like that or in the right hand side. Anything? Yes, fine. The right hand side based on the direction of your thumb, right? And I show you the two arrows. I like the right hand side because I want to now show the figure in the 2D direction, right? Instead of just.
Quick question.
Okay.
You're drawing in the middle and you're drawing on the right, right?
Yeah.
So your MZZ is going to the left, so upwards.
MZZ.
Yeah, on the left. Yeah, so it's going counterclockwise.
Yeah, here. This is MZZ.
Oh, okay. Okay, yeah, I was just trying to see
just look at your right hand rule, and look at your thumb direction, your thumb finger. Right?
Okay.
Okay. And now let me, okay, which means, okay, this is A, this is B, this is C, this is D again, this is A, this is B, this is C, this is D. And now let me show in the 2D direction. It was easy because now it's good. We find everything. And now just what I want to simplify the problem. Okay, now this is okay. So this is center. And okay, I said if the force is compression, okay, I said last lecture, if the force compression, I would like to show with this notation. If the force tension, I want to show like that. But here the force is compression, right? I want to show the force P in the center like this, okay? And this is Z, this is Y-axis. So here we have MZZ, or you can write MZ or MZZ, it doesn't matter. And here we have MY, right? You can show MYY or MZZ, it doesn't matter. So, okay. Now let's review the, okay, this is good. Also, I wanna again look at each case separately if it's confusing. First, just we wanna find the stress from the actual force P. We wanna find the stress from moment mz. We wanna find the stress from moment my. Right now, let me, since these are some, I want to show lots of details, but for sure, for your homework or test, you don't need to separate all this figure because this is a initial examples. I want to show, so you can, and instead of this also just draw the 3 case, just separate, right? And then we can discuss more on that, right? Okay. So first case, just a stress based on actual force, right? This is a actual force. We said what is the formula is P over A. Okay. Let's see here. Let's write mz, right? This is direction of C, this is direction of Y, this is direction of C, this is direction of Y. So formula would be mz y I z, right? That's the formula for that. And this is Z, this is Z, this is Y. And third one is the moment in that direction. Formula for this is my times z divided by iy. These are not new. These are the previous formula. Yeah, just I am. So we should add or subtract these two. So let's write the index for each one. Let's just this one, for example, 1, 2, 3. Right. So the good things is, so okay, what do we need to? So this is point A, this is point B, this is point C.
Professor?
Yes.
What chapter is this from again?
Chapter 4. This is point A, this is point B, this is point C, this is point D. Okay, so for each point we should find 3 stresses, right? One based on the actual, the other one from the moment in direction of Z, the other one based on the moment in direction of Y. So which means we need P. So we have P. We need to find M. Okay, we can find M, MZ, and MY. The other, so also we need the moment of the inertia. That's good. So for Y and Z, it's okay. So for example, let me show you the other. So here, for example, here for A and B, we need this Y, right? For C and D, we need this Y, and both of them are the same, right? Because the center is the middle. In last lecture, in the T-shape, center was somewhere else, then the distance between the center to the point is different. But here, the center in the middle, the distance is the same, right? The Y. So what does that mean? In this problem, y is 6 inch, right? Just half of that. So for the esters here, the z for A and D is this one. This is z. For B and C is this is z, right? So what is z here is 4 inch, right? Because its total is 8 inch. Half of that is so it's very easy now. So we don't need much more calculation. Just so now, okay, we need to find. So we have P. We need to find A. We need to find MZ, MY, IZ, IY. After find all of them, we can find the esters, and then once we want to add it, we should check which one under tension, which one under compression, right? So that's a very, very important part, that part. So, but before going that, let's just find the initial part, find the value of MZ, MY, IZ, and IY, and also absolutely area, okay? Let's find together. So also, let me here, maybe this is the 8 inch. This is 12 inch, okay? So let's start it. MZ is P times EY, right? 20,000. What is EY?
3.
3. 60,000. What is the unit?
Pound per square inch.
Pounds inch.
Pound inch is a moment, right? Pound inch. Thank you. It's 20,000. What is easy? 2.5. That would be 50,000. I did something. It's pound inch, right? What I wrote. It's the pound inch, and also this is pound inch. Okay. So, okay. This is NZ and Y. Let's find IY and IZ together. Okay, let's first IZ. IZ, look at this picture. Oh, look at this one. IZ is BH cube divided by 12. What is B?
8.
8. What is H? Definitely 12, right? What is IY? So here, HP cube divided by 12, right? And H is, for IY, H is 12, right? B is 8. Okay. Okay, now one more. Okay, for A is easy, just 8 times 12, right? You don't need to write. So just, okay, if you find MZ, we have IZ, we have MY, we have IY. Y and Z also is given. Y would be 12 divided by 2 is 6. Z is half of the here, 8 divided by 2 is 4, right? Y is the 6 inch. Z is 4 inch, right? Just this dimension, right? So now let me find, okay, we want to go over for each point separately. A, find the estimates for, okay. One thing we should do, we can do something right now. Let's find the value of sigma 1, sigma 2, and sigma 3, right? Maybe it's good to find sigma 1, sigma 2, sigma 3 without sign, just magnitude, just absolute value. And then we can put with the sign in the once find, because the ester is different between A, B, C, D, only a sign, right? Okay. So one thing is it would be better if I can write here. Can you see my writing? Can you see that?
Yeah, we can see it.
Yeah. So for the P actual force, yeah, the P over A, right? What is P? P is 20,000 divided by A, just 12 times 8, right? Cross section area for rectangular is just 12 times 8. The answer I have, it's 208.3. What is the unit?
PSI.
PSI. MZ divided by MZIIZ. What is MZ? MZ is 60,000. What is Y? 6 inch. What is IZ? 1152, right? Is 3 over 312 point. Okay. This is sigma 1, sigma 2, and sigma 3. Just MY, Z, IY. What is MY? 50,000. What is Y? It's 4, right? What is IY? IY 512, right? It's 390.6 psi. Okay. Now, okay, we find everything. We find sigma 1, sigma 2, sigma 3. And now we want to go one by one. For A, which one is positive, comparison, which one tensile, and then add or subtract. So what I need to go to the other page, and in the other page I can redraw again these 3 figures, right? And you don't need to read right. So here we have if based on actual forces is this is sigma 1. If I miss, since I'm redrawing, if I miss something, for example, if I did something wrong, just let me know. This is MZ, right? This is A, this is B, this is C, this is D. Yes, sigma 2. We find also we solve sigma 2. And this is MY, right? So, okay, sigma 3. Okay, let's see, right. So for sigma 1, we don't have any problem because the force, this force is compression, right? Which means sigma 1 for all the cases is negative, right? Is a compression. Sigma 1 is P over A. Now, okay, now I wanna just solve together. For A, so put your thumb in direction of MZ. Point A is compression or tension?
Compression.
Compression, thank you. Negative. Point B.
Also compression.
Compression. And definitely point C and D is under
Tension.
tension. Now for sigma Z, put your thumb in direction of MY. Point A.
Tension.
Tension, thank you. Point B.
Compression.
Compression. Point C.
Compression.
Compression. And point D.
Tension.
Tension. It's good. So, okay. Now we have sigma 1, sigma 2, sigma 3, yeah, right? From last page. Can you, what is, maybe I need to look at my notes because I don't want to go back to the, so just I'm writing, if I did something different, just let me know. Sigma 1 is, here is negative 2.8, right? 0.3. Sigma 2, is this right, this value?
Yes.
Yeah, thank you. I want to just rewrite. Just check my sign if I did something wrong. No. Okay. I know there is something in the chat, but let me just finish up this one. And then I, so it's interesting, right? Point A under compression because negative, point B negative, compression, point C compression, point D positive, right? The final. So, okay, these are the calculation. Can you explain the right hand rule again? 390.6. Oh, thank you very much. Let me just, yeah, thank you. Let me write it. So the rule. Again, so first, yeah, the sign is very similar to the last problem in last lectures, right? But right hand rule. So the first question you asked me about right hand rule, right? That's a static. So in the static, you know, just if this is D and this is F, right? Just put your arm in direction of D and then it rotate like that, right? And then your thumb is to the desktop, right? Just rotate it to the D and F. Then your
Yeah, away
thumb.
from you.
Say that again.
Away from you towards the screen is the thumb.
Thumb. Set D times F. So it is rotating, right? If you rotate, then your thumb goes to the screen, right? if we have F here, if D, and then it's is in direction, for example, counterclockwise, right? Then your dump is go to your face, right? That's right rule hand. That's right rule hand, right? Compression always negative, tension always positive. And for the sign, yeah, here again. So for example, let's review a sign for one of them. For example, put your dump in your direction of MZ, okay? And then your 4 fingers, the other fingers, compress point A and B, right? It's compress point at A and B, which means A would be sigma 2 negative and B sigma 2 negative, right? And then C and D is positive. And now put your dump in direction of MY. Then the other 4 finger compress point B and C. Therefore, sign for B and C would be the negative, right? And or if you wanna look at from this direction, just look at just assume you are looking this section here, right? Then yeah, just let me maybe right here, right? Then which means you have something like that, which means if you look at here.
For sigma 1, did you just assume it's all in it's all negative because it's going into the page in compression?
Yeah.
Okay, got it. Thank you.
Right? If you look at here, and then you have the MZ is look like that. This is MZ, right? In top, we have top under the compression, right? And then bottom under the tension. But maybe since it's 3D again, maybe it's difficult to imagine, but this one is good. Just look at here, maybe it's easy to understand. Put your dump in direction of MZ, and your 4 fingers compress A and B, right? Which means that's compression. And the other points below the Z-axis would be under the tension, right? At the beginning of this chapter, yeah, once we draw those figures, the beam, the length of the beam and the sections, then yeah, we discussed this one at that time. And then we said, okay, for that section, 3D section, maybe difficult to imagine. Then in the 2D section, it's very easy to, it's much more easier to imagine. Just put your dump in the top or below. Okay, I want to go back to the first one. So
for sigma D, why is there a D next to 494?
Say it again. 494. 4.
Is that under compression or tension for D? Sigma D, very bottom.
The which part?
The 494.8.
All the way bottom right corner.
Oh, here is, I know. I think it's tension, right? I don't know why I wrote D. Yeah, it's under tension, right? Because it's positive, right?
Okay, that's what I thought.
And somebody asked me to go to the previous page. Yeah, you can miss, if you miss something, just you can.
Actually, I also had a question on this slide about the IYs, your BH and HB. The changes, like what are we looking at exactly there?
Yeah, in the once we talk about moment of inertia, let me go to the next page and write something for you. In the moment of inertia in general, right? Moment of inertia, let's look at in general. You can write like that. In this problem, we have Z and Y, right? Okay, this is Z and this is Y, right? For example, this is B and this is H. Formula, just you need to you don't need to derive the formula. We already derive, but you need just to memorize. Or yeah, IZ always is BH cube. Yeah, we derived this formula before, right? we prove this formula. And YY is HB cube, right? This is for rectangular. For example, for circle, we have I. If this is R, is PR to the 4 to the, what's that, 4? Yeah, that's for example for circles.
Okay, so technically it's always perpendicular side multiplied by parallel side cubed, right?
Yeah, exactly. It depends. Yeah. Mhm. So these are the stresses, and now the question is, now we want to talk some. It's not new, but it's maybe you should take care about this. The question is, okay, in last lecture we talked about neutral axis, right? And neutral axis, once we talk about neutral axis at the beginning of this chapter, neutral axis is the axis or is a place the stresses is 0. We don't have stress at that place or at that point or at that line, something like that, right? And in previous example, that was easy to measure because the reason is, okay, we have only one moment and we know, okay, in the top is positive, in the bottom is negative, and then we use a similar triangle, something like that. Here, the problem is we have 2 moments, right? If we look at the moment just based on MZ, we said, okay, top is compression, bottom is tension. Okay, in the middle is a 0. That's the neutral axis. But if we look at this MY, then MY, okay, here B and C compression, A and D are tension, right? Then this one, the vertical line is neutral axis, right? So, and also the stress from the P add to these 2. Right now, it's very difficult just based on each one find the neutral axis because we need a neutral axis for whole the case, right? We want to see what's the final stress at the end, at which point is 0, and where is it? Okay, so now we need to find the neutral axis. We need to use the original formula, and let me go to the next page. I want to show right formula and this shape, and then discuss in this general case what's a technique to find neutral axis, which means at which place of this section stress is 0, right? So let me draw the section again. This is a section. This is Z direction. This is Y direction. Let's see. This we don't need to write A, B, C. Okay, let's write A, B, C, D. Okay, and okay, and the formula is P over A. Let me M Z Y over I Z M Y Z over I Y, and we don't know it's maybe positive, negative. It depends on which point, right? The only thing we know, P over A is negative because the force is compression, right? So now we need to look at this formula and just remember the definition. Definition of the neutral axis is the place of the section which the stress is 0. Then we said, okay, just we set up for now. We want to find the neutral axis, which means NA, right? So we set sigma 0, okay? Just sigma 0. Now, in this case, we want to forget about mechanics of the material and just use the mathematical technique, right? Only just the math, just the math. Okay. Okay. First, we pick the just you know, the difference between A, B, and CD, or the difference between the point. So look at the center. Look at the center. We have 4 area, right? 4 quadrant. 4 quadrant. Maybe here. This is 1 quadrant. Maybe here. Maybe here. Maybe here. Right? You know. And here, what's the? This is MZ, right? MZ here and MY here, right? Okay. So what's the difference between 1, 2, 3, 4? The difference it's the difference between A, B, and CD, right? Look at A. A based on MZ is under compression, right? Which means any point in this quadrant, right? Based on moment, MZ is under compression, right? Because it is above the z-axis, is under compress, and the below is under tension, right? So, but for MZ, here is under the tension, right? Point A based on MZ is under tension. So A for MZ is compressive, but A based on MZ, the sign A is under tension. And the same for the B. So for the B, for MZ is under compression. For MY, sorry, this is MY, right? This is MY. This is MY. For MY is under compression, right? For MY, B is under compression. For MZ also compression. And for C, for example, based on MZ is under compression, but based on MY, based on MZ is tension, MY is compression, right? Which means, so that's the difference between A, B, C, D, and difference between the area 1, 2, 3, 4, right? Just we pick 1 quadrant, right? Just maybe we pick this area, only this one, right? Just pick this one. And now let me redraw this one. So the only difference between quadrant is different between A, B, C, D, right? One is based on each moment is under compression or tension. So I pick this one, and okay, I pick this is the Y direction in this. So since I pick this one, let's Y direction positive here and Z direction positive, right? So I just pick this area, right? And now I want to just use the math. So let's rewrite here 0. What is P over A? P over A is 208.3 with that's the compression. So now in this quadrant, right, just only here, which means point A, the area include point A, right, is MZ here. We have MZ here and MY here. Based on MZ, point A and all the point here is under the compression. Therefore, just we write the negative sign here. Only write the negative. 60,000 MY and Y divided by what is IZ? 1152. Okay, MYZI, point A based on MY under the tension. So I put positive 50,000 Z, any points, we don't know any points here. Okay, divided by 512. Okay, now it's good. Look at now, just look at as a mathematics, not material. This is an equation based on Y and Z, right? So if we put y, we can find z, or if we put z, we can find y, right? So now let's just find the value. Find the value in this quadrant, right? I wanna put, for example, let me with the other color. If z is 4, what happens if z is 4? If z is 4, let's just find it, right? Just substitute z at z4. Minus 60,000 divided by 1152 would be negative 52.083y. Okay, let me write all of the general formula, and then I pick z4. Okay, 97. Yeah, let me write. This is a general formula. Okay, let me. I simplify the formula. Okay, this is this formula. Okay, this one. I can write like that. Okay, this formula to this. And now let me write with the green. Okay, if z is 4 inch, right? For example, at this point. Times 4, right? And then now that's algebra is equation. We can find y. What is y? Is 3.5 inch. So which means the first point is 4.3. So it's very interesting, which means at point 4, at point z4 and y 3.5, stress would be 0. For example, here. This is 1 point. 4.4 and 3.4, right? So yes.
Are you also allowed to choose z is equal to 0?
I wanna okay, exactly. I wanna find. Yeah, we can put. We can put 0 equal to 0 because right now, you are right. We need only 2 points to draw a line, right? You can pick any arbitrary point. Yeah, you can pick, for example, z to the 0 and find y, right? Or another point, right? It doesn't matter. So let me put, for since I put the 0 equal 4, let me this time I put the value for y, not necessarily z. Let me put y, for example, 6 inch. Maybe y is 6 inch. Is, for example, here, right? This is 6 inch, and then find z. But you are right. You can pick any value for z and y.
But cool question. We cannot pick greater than what was given on the sides, right? Like, for instance, we can take, let's say 24y.
That's a good question. Let me write this this line. Maybe is exactly related to your question, and then we can discuss about it. But your question is very good.
Out of boundary.
Your question is good. But let me write this line. It may be directly to write your question. I know your concern. But let me write this one, and then I'll be back to your, because this is very similar to your question, the result of that actually. Because of that, I want to. So plus 90 times z, right? Just z. Z, and this one z is 5.33, right? And this is 4" and Z is out of boundary, right? Because this is 6 and this is 6" and this is 533, right? Out of boundary, right? This is 533 and this is 6 is out of boundary. Okay, let's set something. Okay, let's draw this two point and draw the line.
Technically, if you draw a cross, it's all going to be the same, right?
Yeah, but okay, you know, we are looking for the neutral axis for this figure, but we find the point outside the boundary. It's okay because we find this point based on only this equation, right? This is the equation, and the equation of the line. What is the definition of the line? Line is something from negative infinity to positive infinity, right? But in this application, we need only in this domain, right? Maybe somewhere here. So then we said, okay, this is the equation of the line. So you can pick value for y out of the boundary, or pick the value z for out of the boundary. Maybe you get the results out of the boundary like that. But at the endpoint, said, okay, that's fine. This we need this portion. This portion is neutral axis. Because do you remember, to draw a line, we just need the 2 points, right? To draw a line, and then with the same slope. And look at here, this is a line because y and z, this is the equation of the line, y and z, equation of the line. Oh, okay. So, but we need just 2 points to draw a line, and then at the end we should justify. So the purple, this purple is neutral axis, and let me draw nicely. Maybe let me draw. So okay, we use the math. But neutral axis is this, and we are done. This is neutral axis for neutral axis, which means at this line, stress is 0. Any point in this line, stress is 0. That's the neutral axis. And there is another interesting thing. Maybe you like it. Look at this line. Look at this line. This line goes from this quadrant. Let's, if for example, this is point A, this is point B, this is point C, this is point D, right? It covers some point here, some point in the second quadrant, point, some point here, some point here, but no point here. It doesn't pass B. It doesn't pass the second quadrant, and it makes sense, right? Because if you back to the equations, just look at point B. Look at B. These 3 guys, all of them are negative, right? All of them are negative, which means if we change sigma 1, 2, 3 from point B to any point here in this quadrant, and all of them are negative, there is nothing to cancel, which means always this sigma in this quadrant always is non-zero. But look at the sign in A, C, and D. At least one of them is positive, which means if we go from A to the other point in the first quadrant, any point, many here, then at some point, maybe this positive cancel with these 2 negative, and then we reach the 0. Also here sigma 2 is positive, which means somewhere here, maybe here, right? Then this stress maybe cancel these 2. Also here, but if sigma B which means this quadrant, then all of the stress is negative. So there is no way to reach the zero stresses, right? So yeah, then you can analyze that one. So you know, if you compare this figure with the equation, here the area include A, we have these points. In these points, sigma 1, sigma 2, sigma 3, if we add all of them, cancel each other and reach the zero stress. And in this quadrant, these points on neutral axis, in this quadrant here, but the neutral axis doesn't pass in this region. So by the way, this purple line is the neutral axis.
Hey, Professor.
Basically, when we to find the neutral axis, we just need to find the equation of the line. Yes. The equation of the line, because look at the equation. The equation is based on y and z, right? Which means the neutral axis is the equation of the. So neutral axis here. Once we have both moment in direction of y, moment in direction of z, we have a line. But if we have the same as the problem in last lecture, we have only one moment. That was very easy. If you remember the last lecture, we used just similar triangle, and neutral axis just only this point, right? At this point, the stress is 0. Is P perpendicular here. So P perpendicular to the cross section at any point, A, B, C, D, any point. P is the perpendicular. Right here, if we have this cross section, P is perpendicular to that. So yeah, so somebody asked me question. Okay, and do we need to simplify as? No, you don't need to simplify. So don't make the challenge for yours like the calculus. Just that's the equation, and then pick 2 points. Put one y find z, or one z find y, or 2y find 2z. Just we need 2 points, and then draw the line. Right? You don't need to simplify. Don't spend time for that. This because we already know this is the equation of the line. Okay. Somebody asked the question. I mean, yeah, it's perpendicular to neutral axis. Okay, once the force P perpendicular to this surface, right? Then it's perpendicular to any line in this surface, right? It's also this neutral axis. But it's perpendicular, which means it's it's to the plane. It's to the plane. P is to the plane, right? We cannot see P. P is to the plane. Yeah, like look, we can show P like that in the simple, right? If you look at this view, P look like this. I mean P as a point. What does mean P as a point? I don't know P as a point mean. What does that mean, P? I don't understand what you are saying. P, we have, this is 2 points, and using these 2 points, we just draw a line. We just draw a line, and that's the line. Yeah. Neutral axis in the YZ plane. Neutral axis is in the YZ plane, right? That's the right thing. Yeah, the loading is perpendicular to section. Okay, that's about this one. Do you have any question about this problem? I wanna solve a short problem because it's very similar statics, but only in one moment. It's very similar, but there is a little bit some points, and that problem is maybe is interesting to you. And it doesn't have more calculation. We want to find just stresses and 2 points, but it looks like statics is a very good thing to can imagine a real beam problem with 2 different loading, right? I want to solve this problem. And after today also, I want to give you the homework based on these topics today and Tuesday. I want to give you the homework assignment, and that was very good. You can spend time just to imagine about the sign of tension or compression or something like that, right? So again, this class, you should just solve the problem, just practice, and especially first realize the problem in my lecture note, right? And this problem, I think, is very interesting. It looks like a statics problem. Just we have h. This force is h is 50 pounds. Again, we have a cross section, just rectangular cross section. Let's just direction of x, and this force P goes there. 200 pounds. And now if you look at this view, we have a cross section. The cross section look like that. Something like this. This is rectangular. This is 3 inch. This is 4 inch. And P is just here. This is point P. It's just compressive points, compressive load. This is P. With this distance is 1 inch. Okay, this distance is 1 inch. We want to find ester. So this is a beam. This is a beam. We want to find esters as point B and point C. So okay, first just at it's section BC. It's section BC. This section. So we have this is a support, right? We have a moment here, right? Let's just this moment here, right? And because of equilibrium, let me write it the other. And also we have a force P here, right? And now I want to find the moment, just summation of the moment equals 0, just a static. And now I want you help me. I want you help me just from the statics view, not the mechanics view. Let's this section E, right? Here is section or something like that. Okay. And summation of the moment about E. E means the support, right? So okay, how many let me erase this one. I don't want to put here, maybe it's confusing. Let's see. Okay, I want to find moment, this moment. How many loads we have? 2 loads, right? And the distance of the length of the beam is 10 inch, right? So, and this direction is positive. We have, and this is ME, right? ME. So we have 2 more loads to make the what's that? Moment. Can you tell me to write? What's the moment from load H to the point E, to the section E or section BC? What's that?
So it's going to be a minus 50 times 10.
Right, it's clockwise. 50 times 10, thank you. How about the next one?
That one is going to be also minus 200 times 1.
Right, minus because times this arm. The arm is 1 inch. Thank you.
Clockwise also.
Yeah, thank you. That's very good things. Equals 0 is equilibrium. Therefore, M at the support would be 700. What's the units? pound inch. Okay. Okay, we find moment. Also, because of the equilibrium, we have the force. We have the force here, and now we wanna find the stress and for point B and C. And now in this section, we have two things: axial force P and the moment E. And just I want to ask you, just look at the, so okay, this is a force P, right? This is equilibrium. This P in this direction, that P in this direction. It's the same, because so it should be canceled out. So okay, so P is compression. It's compression on BC, right? Okay, I want to ask you if I want to write okay, the formula. Let me sigma B P over A Y over I sigma C P over A MI over I. So definitely P is compression, is negative, negative. For B and C, which one compression, which one is tension?
B is going to be tension and C is going to be compression.
C is compression. Thank you. Negative, positive. This is ME, right? Use the dome. You put your okay, okay, just here, you know. Look at here. Okay, this one. If your right hand put your fingers in direction of ME, you compress C and then have B here, or right, you know, just to compress, just put your fingers in direction of ME is counterclockwise, right? You compress C and then T is under tension, or you can show like that, right? This is MC, right? Or this is ME, right? Just a section, pick a section. This is also M because of the equilibrium. Then its shape look like this. This is the neutral axis, for example. The shape would be look like that, right? So this region, including point C, if this is point C, is under compression. This region under, including point B, is under tension. Okay, that's look like that. This is one way to distinguish which one is positive, which one is negative, right? This is for point B. This is for point C, right? Or the other way, you can draw in the 2D direction, right? If this is C, this is B. ME, the direction would be here. If you like to write in this direction, and then this is compression, and then this is tension. Anyway, if you are comfortable, you can just look at this one. The easiest, just look at the original. C is under compression, or you can imagine the deflection shape. The below is compression, the top on tension, right? Tension. Or if you wanna draw like that, this is direction of ME, right? Direction of your thumb, and then C and B, right? So, and let me, the last thing, just find the values, just substitution and find the value of that, right? Let me just help me to write the value for, let's this is something like a statics and vectorial, right? What is P? P is
200.
200. What is A?
12.
12, right? 4 times 3, right? Exactly. Plus, what is the moment is 7. Again, guys, don't put the positive or negative for moment, just magnitude. Right? What is Y? From neutral axis to point B, what is y?
2.
2.
2, exactly. 2 inch. Let me write I here. BH cubed divided by 12. Again 2, because this is again, is y is a 2 inch. It's half of 4 inch, right? This is 2 inch, right? Moment of inertia would be the same. The answer I have for sigma B, I have the answer negative positive. I have 70.83. What is the unit? PSI, right? And the answer for this guy, I have 100. Oh, 0.17 PSI, right? This is the tensile stress. This is the compressive stress, right? Does it make sense to you? It's not too long because we have only one moment and
So actually I had a question about that. If let's say we were shifted somewhere to the right or to the left, then we would have had a 2, right?
Sure. P, you are talking about the load P?
Yeah. So you see
Definitely.
how like it's
Definitely.
one down.
Yeah, you have another moment. That was, we have additional. Then we should add m times, for example, x divided by I, the other I, right? Right.
So then we would have had a IY and IX,
Yeah,
right?
then we should care about the index also. Which one is IX? Which one is I? For example, Y, which one is MX, MY?
So in this particular case, we're just using the IX, supposed, right?
This particular, no, because X is this direction.
So
Let's
3
define,
parallel and 4 perpendicular.
let's maybe this direction is Z, for example. This I would be Z, right?
Oh, yeah, the Z. I meant horizontal.
Yeah. Yeah. Let me go. Okay.